Okay, good morning. This morning we are looking at site windflow analysis and design. The software we're going to use is Autodesk Flow Design, and this is the link for downloading the software. The software is free as usual. Now, this is an area of software which has been changing every year. 2 years ago we did this simulation in Autodesk Vasari. Last year we were doing it in Project Falcon, another Autodesk product, and we were doing it in the Flow Design plugin for Revit. But it's changed again this year. So in Revit 2016, the Flow Design plugin has come back out again. So we now do this simulation in Autodesk Flow Design as a standalone piece of software. Autodesk Vasari no longer is supported or offered, so we can't do it in Safari anymore. So we do it in Flow Design. It's a bit of a shame in a way, because when it was a plugin for Revit, you could perform the simulation directly in the Revit environment. But equally, it wasn't a very good plugin, and I think that's probably why they've brought it out. Okay. I would say as well, this is probably the weakest piece of software that we use in this module. So it's not a terribly advanced piece of software. It is getting better, but it's still kind of early stages for it. So we still show it to you, we still demonstrate it, and it still gives you an understanding of wind flow. But what you should be clear about is that this is not a kind of very high level computational fluid dynamics software. So I demonstrate the software for performing urban wind flow. So looking at a site and looking at the external wind flow on that site. And for that purpose, it's okay. It's quite reasonable. You should not confuse this with interior ventilation simulation. If you look at this software, you will find people online demonstrating it for internal wind flow and ventilation flow, but it's not really good enough for that. So I'm not suggesting you use it for internal simulation. Okay? If you are interested in internal simulation, then the product you could look at is Autodesk CFD, okay, which again is free. It's a much more advanced package, but it's too much to cover in this module. In this module, we try and cover a whole range of simulation types. If we were to go into Autodesk CFD, we'd need to spend 10 weeks just looking at that, okay? But equally, I've had some students in previous years who were interested in CFD. They downloaded the software and they did teach themselves how to use it. Okay, so Flow Design, this is where you can download the software. And we're going to talk about a few principles in terms of wind flow design. So the first thing to understand is what's called the Beaufort Scale. And the Beaufort Scale is a method of understanding the velocity and the impact of wind. So if we look at the Beaufort Scale here, you've got a grade down the first column from B0 to B10 and a description. So for example, B5 is described as a fresh breeze. Then we've got the corresponding wind speed in meters per second, and that's measured at a height of 10 meters above the ground. So in an urban situation, that would be measured 10 meters up. You might also look at wind velocities at ground level, but in terms of the Beaufort Scale, it's measured 10 meters above the ground. The reason being that if you measure wind directly at ground level, then anything such as a car, a low hedge can impact that wind velocity. So we tend to measure it a little bit higher. And then the effects. So for example, B5, fresh breeze, 8.0 to 10.7 meters per second, limit of agreeable wind on land. If we look down at a stronger wind, B8, 17 to 20 metres per second, generally impedes pedestrians, walking difficult to control, huge difficulty with balance in gusts. So it's a really good method of understanding the wind. Okay, and as you see at the bottom here, wind speeds measured at 10 metres above the ground are reduced to about 75% at head height. So if you were measuring that wind at sort of head height, you could expect that to be 75% of the measurement at 10 metres above the ground. Okay. Now, in this example I've given you, the wind speed is given in metres per second. If you Google Beaufort Scale, you'll find lots of other charts using kilometres per hour as well. I tend to prefer metres per second. Okay. You'll also find lots of other scales which have little images, little pictures, which are all, all fine. Now, this is an extract from a guide that I've given you the link to, and this is how, in this particular city, how they are applying the Beaufort Scale. So what they're looking at is, for different activities in the city, how would we judge the wind? So, for example, if we go back, let's look at our B5. Fresh breeze, 8 to 10 metres per second, limit of agreeable wind on land. So, in this design guidance, if you were designing a park or an entrance, B5 would be considered tolerable. So it would be considered kind of acceptable. Okay? If you went to the next velocity, B6, that would be considered unpleasant. And if you went up to B8, that would be considered dangerous. Now, for a different activity, if we look at here, street cafes, for example, then a tolerable wind level would only be considered B3. And if we go back to our scale, B3, 3.4 to 5.4 metres per second. So in other words, what they're saying is, for a cafe, you need much more shelter from the wind for that to be acceptable. Because I guess if you're sat in a cafe and the wind's sort of blowing everything around and blowing your clothing, you would probably go inside. So important to understand that depending on the activity, you can have more or less wind. So for example, if you're walking, tolerable would be B6. If we go back, B6, a strong breeze, 10 to 13 metres per second. So umbrellas used with difficulty, force of the wind felt on the body, and in this guidance that would be considered tolerable. So in other words, if you're walking about a city and there's quite a strong wind, but you're walking, you would think, well, that's acceptable. And you're walking along the street and, it is a windy day. But it's sort of different. If you're sat, for example, in a park or a plaza which has been designed, experiencing that level of wind, you would consider it unacceptable because you're perhaps sat down, it's a space which has been specifically designed, so it should have been addressed. So really important to understand those different levels of tolerance. For our case study assessment here, based down on the forecourt, think about the activities. So we've got, down there, we've got walking. So on parts of that plaza, people will just be walking. So people will be walking past the Arts Tower, heading to the Students' Union. So they're just walking. So they might consider B6 tolerable. If you're just sort of strolling around, you would only consider B5 tolerable. If you're on a kind of plaza, so if you're, for example, sat in the plaza downstairs, you go out there to have your lunch, for example, you'd only consider B4 to be tolerable. And if there was an outdoor cafe, you would only consider B3 to be tolerable. Now, if you look at the bottom row, acceptable if speed occurs less than. So, quite important here. This level of wind speed, B8, which is gale, 17 to 20 metres per second, would be considered acceptable if it occurred less than once a year. So less than once a year is actually 0, but I think it means probably once a year. So in other words, once a year you would probably accept if there were some really strong winds. Okay. If that happened every month, we would not find it acceptable. Then if we move down the scale, if we go, for example, to our tolerable level of wind speed, we'll find that acceptable if it occurs, let's say, less than once a week. So once a week or thereabouts, we'd find it acceptable. We'd not find it acceptable if every time you walked out the front door of the Arts Tower, there was a huge wind blowing you over. Okay? Now, what you might not have seen yet, but you will, that little gap between the Arts Tower and the library, because of the funneling effect, have you seen that? You get some very high wind velocities through there, and it's a real problem actually. And, you know, people have been knocked over. Many architectural students have walked down the street with their lovely architectural models, and their models have gone off into the sky. And you know, and that's clearly not acceptable. It's even dangerous. And probably what we're getting there, because of the wind funneling effect, we're probably in the sort of B8 to B9 level. But it's probably happening, I don't know, 4, 5, 6 times a year. So that's, you know, that's something that's clearly a problem. Okay, now I'm not going to make you experts in terms of wind design, but I just want to give you some familiarity with the principles. Now, you should be clear, there are experts out there, and they're called aerodynamicists. Now, these are people who have studied Windflow, and they, you know, they are the real experts. Now, in architectural practice, as an architect, as a designer, I think it's great to have an understanding, and it's great to do some early stage design, but just bear in mind that there are experts out there as well. Okay, let's move on. This was some further guidance this is from Wellington City Council, which I thought was very, very useful guidance. Now, what they're saying here is, depending on the existing wind speed, what will we consider acceptable in a new development? So if the wind is, I think this is supposed to say 0 to 10 in here. I need to change that. If the existing wind is in the 0 to 10 metres per second, and the wind speeds are going above that 10 metres per second, sorry, this should say 0 to 15 metres per second, then in this city, the designers need to reduce that down to 10 metres per second. If the existing wind speed was measured as 15 metres per second on site, and as a result of the development, so as a result of the building, if that wind speed was being pushed above 15 metres per second, this is what the designers would have to do. They would either have to reduce it to 15 metres per second, or, this statement at the end, overall impact is to be no more than existing. So in other words, what they're saying is, if you're experiencing winds above 15 metres per second, then your design must not make that worse, because that's quite high wind velocity. And as a designer there, you would have to make sure that your design limited to 15 metres per second. And it's the same, we've got 15 to 18 here. If you're if the existing wind speed is 15 to 18 meters per second, and your design is creating a wind exceeding 15 meters per second, you actually have to reduce it to 15 meters per second. So you actually have to make the wind velocity lower than the existing. If it's above 18 meters per second, you have to just make sure that you don't make it any worse. So you have to reduce it. In fact, you have to reduce it to 18 meters per second. So what this guidance is saying is high wind speeds can be quite dangerous, can be quite unacceptable in a city environment. So as a designer, you need to control those wind speeds. And this is the kind of guidance that you can use when you're assessing your site at the bottom of the Arts Tower here. Okay. Methodology. You need to understand your site wind conditions. And when Windflow was a plugin for Revit, this used to be all done inside Revit, but now you have to do it in a different way. So you need to understand the wind of your site. Two possible ways. You can create a windrows from your Revit energy analysis, which we've already demonstrated. So this is a typical windrows. This is the windrows for a whole year. Or you may extract that data for specific months of the year. You can also create a wind wheel in Climate Consultant, which is a piece of software that I've demonstrated to some of the students. And that looks like this. So you've got two options there. Both will give you the same results, but just depends on your preference, really. Okay, so if we just have a little look at, I'll go back to the Revit windrows. Just to understand the windrows a little bit more. So in this particular windrows, the colours relate to the wind speed. The length of the bar relates to the percentage of the year where you experience those wind speeds. And the direction is the direction that the wind comes from. So for example, if we look at this bar down here, we're getting wind speeds in that dark blue, 57 kilometers per hour, but it's a very narrow dark blue bar, indicating it's for a very, very small percentage. If you look at this light blue, which is the 21 to 29, this is kilometers per hour. The Climate Consultant one uses meters per second. So in that band, you're getting that for quite a much larger percentage of the year. Okay. These combined metrics indicate where the wind is coming from. If we look at the Climate Consultant, if we look at this is a specific month. In Climate Consultant, this middle part of the chart, the key is here. What you've got, the spiky orange triangle, is the average wind speed. And this is in meters per second. The dark orange is the maximum wind speed, and the yellow is the minimum. So for example, if we look here, see where my mouse is there, the light orange spike, the average, is saying that the average wind is 6 meters per second from this direction. The maximum measured wind is 12 meters per second. So thinking back to our Beaufort scale, anything below 10 meters per second was generally considered quite acceptable. So if you were interrogating a site using this windrows, you might look at this and say, well, we don't need to worry too much about these velocities below 10 meters per second, but we're probably more concerned with these peak velocities. So if you look at these darker orange, we're getting velocities in the sort of 14 up to 16 meters per second. So quite fast wind velocities. In Climate Consultant, the yellow bar here is then the percentage of hours that you're experiencing the wind from these directions. Okay. Now, in terms of methodology, with the wind, you have to sample throughout the year. So the wind, if we go back, the wind comes from all sorts of directions. So you can't do a single simulation. You have to look at your wind direction, look at your windrows, and decide where you're going to test. So if I go back to this is the whole year for Sheffield, and what you see is the winds tend to be stronger in the south, southwest, and the west, but you get wind from all directions all year round, effectively. Some sites you get a much more directional wind. So probably, if this was your site, I think you might quite reasonably decide that you're going to test from a range of directions, because the wind comes from all over. Okay. Look for the highest velocities. We're more concerned with the high velocities. Look for the most frequent directions. In Sheffield it comes from all around, but some cities have a much more directional wind. And then you don't need to test the directions that the wind doesn't come from. Think about critical dimensions. For example, the direction of the wind, for example, facing your entrance to your building. That could be a really critical direction. Are there any existing issues on site? So, before you look at your new building, conduct a simulation of the empty site and try and understand if there are any high wind velocities being created. Obviously, you can go out and have a look as well if you have access to the site. Then consider the impact of your new buildings on the site. So you have the existing condition. When you add your new building, does it make it better or worse? Really important. You can't be making that site worse. Are there any site improvements you might want to consider? Would you consider perhaps adding some planting or some walls to kind of shield the existing area? So if we take this site, for example, we've got that problem between the library and the arts tower. Is there anything you could do in your design to improve that? Location and design of outdoor space. If you've got any outdoor seating, then is that affected by wind? Do you need to consider its position? Do you need to consider some protection? And planting. Planting is actually very effective as a wind buffer because it tends to slow the wind down. Rather than just deflecting it, it tends to absorb some of the wind's energy. So that can be very effective. The building level. So, how high is your building? That can have an impact on the wind. The entrance design is important. Ventilation implications. Now, we're not looking at this in detail, but you can test, are there any areas on your site where you're perhaps getting very low wind velocities or very high wind velocities, and they may indicate that they're not very good positions for opening windows. Building size, shape, orientation, all important factors. Okay, a few references. Wind Design Guide you can download here. And Micro Wind Turbines in Urban Environments is another useful document looking at how you might want to harness the wind energy in an urban condition. This one you can download from CIS through this link. These slides are on Mole, so you can get these links from Mole.